Hello everyone and welcome to your explanation for Worksheet 4A. This is the beginning of the matrices unit. You just took the third exam, so hopefully you did well on that. This entire chapter is working on matrices, and basically what matrices are is there another way to solve a system of equations. Now, you might remember back to Algebra 1, definitely Algebra 2, with the different ways to solve systems of equations. We had solving by graphing, which was like the least accurate way, but it was a way to do it. We had solving by substitution, and then we had solving by elimination. All of these, you'd run them through the algorithm, and you'd sort through it, and at the end you would be able to get an X and a Y and figure out where the two lines crossed or where they were equal to each other. So this is another way to do it, and the reason we learn it how to do it this way is because this works for very, very sophisticated types of equations where you have more than just two variables, more than just an X and Y. So you can have up to as many variables as you want. This is used a lot in insurance, in the insurance industry, where you're trying to figure out the best price to charge someone based on, if they're in a flood zone or if they've had prior accidents or stuff like that. So this is used a lot in the real world, and a lot of people don't understand what's happening behind the scenes. A lot of time you just plug numbers into a computer, and computer does all the work for you, but this is kind of the math behind it. Okay, so first thing we need to see is kind of what a matrix is. So we have these two lines up here, and basically all you're going to do is you're going to make sure the X's and Y's are lined up, and then you're going to strip off all the coefficients and stick them into some brackets, kind of like this. So this is a 2x2 matrix, okay? When we talk about the dimensions of a matrix, we always talk about rows by columns. So we start with how many rows are, and rows go horizontally, and then columns go vertically. So this top one is a 2x2. This bottom one, well, there's 2 rows and 3 columns. So that's a 2x3 matrix on the bottom there. Okay, with matrices, we're going to be able to do a lot of stuff with them, but first thing we need to talk about is just adding and subtracting them. So addition and subtraction. So if you're adding 2 matrices, they have to be exactly the same size or you can't do it, first of all. So these are both 2x2 matrices. And to add them up, we just add the top left number for one of them with the top left number for the other one, and we get the new top left number. So for this one, we would do 3 plus 5, and we would get an 8 in the top left. Top right, we would get 4 plus 1 would be a 5 in the top right. Bottom left would be -2 plus 4 would be +2, and then the last one, 6 plus 0 would be the bottom right. So that's how you would add them. Subtraction works the exact same way, but you just subtract. Okay, scalar multiplication is when we multiply everything inside a matrix by a number. So in this case, we're multiplying everything in this 2x2 matrix by -3. So you would get -12 in the top left corner, +6 in the top right, -15 in the bottom left, and then -18 in the bottom right. So you just multiply everything by -3, kind of like distribution, and that's how you get it. Okay, now multiplication is by far the most complicated. So the way this works is you're going to take the rows in the first matrix and multiply them by the columns in the second matrix. So the rows for this first matrix are in yellow, and the column for the second matrix is in blue. So if you do all that, this is what it looks like, and it's kind of a mess, but we have 2 times that 5, and then 3 times that 6. Well, you multiply all those things together, and then you add up the 2 results, and that's how you get your new number in the top left corner. So for the number in the top left, that 2 times 5 would be 10, that 3 times 6 would be 18, so we would get a 28 because 10 plus 18 is 28, and that would be just the top left number. You do the same thing for the top right, bottom left, and you'll have your new matrix. So we're going to be doing a lot of practice with this, but that's kind of where it all comes from. Okay, so let's look at number 1. Okay, so this is the very first one. So it says, what is A plus B? Well, we look at our A matrix, And our A matrix is a 3 by 3. Our B matrix is a 3 by 3. So we are allowed to add these two together because everything has something to add to. So the top lefts added together will be 0 plus 0. And then the next one will be 4 plus 4, then negative 2 plus 4, and so on and so forth. And then eventually, after you add up all these, you're going to get this matrix down here at the bottom. So 0, 8, 2, negative 3, 13, 4, 7, 15, and negative 1. And that is those two matrices added together. Okay, for number 2, let's look at number 2. So for number 2, we're going to do scalar multiplication first. We're going to multiply everything in matrix A by negative 2, and that's what I have here in blue. I just multiplied everything by negative 2. And now I'm going to add that to a B. So matrix B is a 3 by 3. So if we add those together, you're going to end up getting this matrix down here at the bottom. And that's just adding the top left to the top left, middle top plus the middle top, and then top right plus top right, and so on and so forth. So this is what you get. Okay, check your work on these as you're doing them, okay, just to make sure you're not getting too off track. All right, now number 3 is the tough one. So number 3 says A times B. So all of the numbers in here that are green are from the A matrix, and all of the numbers in here that are from the B matrix are red. So I showed all of my work here, but this is what you get. Once you multiply all the rows times all the columns and add up all those results, this is the answer that I got down here. So try this out. Don't just trust my word, trust me for it, but make sure my answers are correct, and see if you can't get this exact same result from that. Okay, let's look at number 6. Now, number 6 is pretty easy if you know the trick, but if not, you could spend waste a lot of time trying to do this. So it says multiply C times B. Well, C is a 3 by 2 matrix, and B is a 3 by 3 matrix. Well, if those middle two numbers, in this case a 2 and a 3, if they don't match perfectly, then you can't do it. So one of them's a 2, the other's a 3, so this one you cannot do, so you say I can't do this because of the dimensions, okay? So let's go to the next one. Number 10. So number 10 is an order of operations. So first thing we're going to do is multiply those two matrices on the right. Well, the first one's a 2 by 2, the second one's a 2 by 3. So we can multiply these, and our result is going to be a 2 by 3, okay? So first row times first column, so negative 1 times 0 plus 3 times 1, and that's how I'm going to get the top left one. I did all of the first matrix is in red, the second matrix is in blue, so that's how these are color coded. And then add up all those, and I'm going to get the black matrix over here on the right, and then the green matrix is the first one that I didn't touch at all yet. So then this is a 2 by 3, this is a 2 by 3, so we can add up those, and we're going to get this matrix down here at the bottom. So 3 plus 3 is 6, 1 plus 9 is 10, and so on and so forth. So that's what you get for that one. Okay, so that is it for the explanation. Really, there's no, these are really tough to explain just because there's something that you have to practice and you have to try and you have to mess up a few times on so you really understand it. So go through these and use my answer key liberally and see if you can't get some similar results to mine. Okay, good luck, and let me know if you have any questions. Thank you.